In the yellow rectangle, there is the mathematical programming formulation for computing a max-min strategy for player I in a two-player normal form game. In this lecture, we show how to translate it into ample language starting from the .mod file. Every model file starts with the declaration of sets. Sets define finite collection of indices that are used to index vectors and matrices of the model. In this case, the only indices that you need are those corresponding to the actions of the players, used to index the strategy vector Si and the rows and the columns of the utility matrix Ui. We assume that both players share the same set of actions and we call it uppercase I. Then we declare the parameters of the model, in this case only the utility matrix Ui that we call uppercase U. Since uppercase U is a matrix, it has two indices, which represent the actions of the players. We specify the two sets of indices within curly braces immediately after the name of the parameter, separated by a comma. Then we need to define variables. There are variables Si representing the strategy of player I, which we call S. The strategy is a vector indexed by the actions of player I, thus it takes only one set of indices within curly braces. Note that variables Si of the model are subject to the non-negative constraints. Ample allows us to easily specify such constraints directly while declaring the variables, as you can see in picture. Similarly, we define variable v, which is a scalar, and thus it does not need any set within curly braces. After the declaration of sets, parameters, and variables, we define the objective function. In this case, the objective is to maximize something. We can give a name to the objective function. In this case, we call it objective. The expression of the objective function is specified after a colon following the name of the objective function. In this case, it is simply v. Then we define the constraints. Each constraint is introduced by the keyword subject to, followed by an optional constraint name. We call the first constraint constraint. Constraints are usually organized in two groups. Each group is indexed over some set. In this case, there is a constraint for every action of the player other than I. Thus, constraints are indexed over J in set uppercase I. Note how mathematical expressions can be straightforwardly translated in ample. Just note how to write summations. You have to specify the keyword sum, followed by the indices over which the sum is defined within curly braces. In this case, there is only one index corresponding to an action of player I. We call it I belonging to uppercase I. In a similar way, we define the second constraint. Note that the constraint is single, so we don't have curly braces after the name of the constraint. This is the final .mod file.